So this is our chosen question, and basically it demands us to find V1, V2, current I1, I2, I3, and I4. So we're going to analyze this question by using the nodal analysis method, where we're going to apply the Kirchhoff current rule at each node with an unknown voltage. So we do know node is a point where two or more branches are connected. So for this particular circuit, we can just choose this whole part here as node number 1 and this another part here as node number 2. So firstly, we need to determine the direction of the current. So we were given 3 current sources, so we can just assume the direction of current according to the arrows given. So this current here is moving into the node, and this current here moving to the node, and another one is moving into the node as well. So from the Ohm's law, we can get the value of I1 and I2, since it states that the current flowing through the resistor is equal to voltage at higher potential, which is V1, minus voltage at low potential, which is the reference node, because the voltage value is 0, and divided by the value of the resistor, which is 20 ohm for I1. And notice that I1 and I2 are parallel to each other, hence why both of them are using the same voltage value, which is V1. So next, by using the Kirchhoff current rule, it states that the sum of current into the node are equal to the sum of current leaving the node. So for node number 1 here, we can clearly see that the current into the nodes are 6 amps plus 3 amps, and the current leaving the nodes are 1 and I2. So we can construct this equation, and remember from the previously derived equation, we can substitute the value of I1 and I2. So we will have this equation, and just simply by solving it, we get V1 is equal to 60 volt.
Okay, so this is not 2. To obtain V2, we are going to do a nodal analysis at this point. So at this point, there are currently 4 current going in and out, and we are going to obtain this equation, which is current going in equal to current going out. Current going out, I3 is equal to V2 over 40, because I3 flowing through this resistor, which is also the same equation as I4 flowing through 40 ohm resistor. So we are going to obtain V2 over 40 plus V2 over 40 plus VA, and by solving this equation, we are going to get V2 equal to negative 20 volts.
Next, we will find the value of I1, I2, I3, and I4. I1 is equal to V1 over 20, so we substitute the value of V1, which is 60, then we calculate, we get the value of I1, which is 3 ampere. I2 is equal to V1 over 10, so we substitute the value of V1, which is 60, then we calculate, we get the value of I2, which is 6 ampere. While I3 is equal to V2 over 40, so we substitute the value of V2, which is negative 20, so we get the value of I3 negative 0.5 ampere. Same as I3, I4 is equal to V2 over 40, so we get the value of I4, which is negative 0.5 ampere. So the negative sign here indicate the current flowing in opposite direction with respect to indicated current in the figure. So I think that's all from us. Thank you.